if the future of artificial intelligence wasn't written in code, but chanted in ancient temples? No, this isn't science fiction. It's something far more astonishing and real. Today we write code in Python, Java, and C++. But some researchers, they're turning to Sanskrit, not for mysticism, for structure. Welcome to a world where temple chants and machine learning belong in the same sentence. If you're a coder, a language nerd, or just curious how machines think, this might just change everything you thought you knew about AI. AI breakthroughs rely on one thing: structure. Machines don't feel meaning. They follow patterns, logic, rules. But human languages, especially English, they're messy. Take this sentence. She saw her orange. She saw her fruit, an orange. She saw her pet named Orange. She saw her orange-colored dress. Same words, different meanings. To us, that's clever. To a machine, that's chaos. Sanskrit is different. It's not just old, it's engineered, algorithmic, structured. It doesn't just speak, it computes. Travel back to 500 BCE. Meet Pāṇini, the mind behind the most advanced grammar system in human history, the Aṣṭādhyāyī. Almost 4,000 rules, not explanations, algorithms, context-free grammar, finite automata recursive systems, root word in, rule applied, sentence out. He didn't just describe Sanskrit, he built it. Just like a compiler processes code line by line, Pāṇini's system processed words, applying logic step by step to build language. And he did this in 500 BCE, centuries before Turing, Chomsky, or computer science were even imagined. Why does this matter today? Because I need structure, logic, rules. And Pāṇini gave us exactly that: a recursive, rule-based system for generating language from its parts. Fast forward to today. In NLP, we use syntax trees, context-free grammars, and recursive functions, tools that Pāṇini effectively pioneered. We're not copying his work, we're rediscovering it, with nothing but his mind and a language that demanded perfection. He taught language to think centuries before AI existed. His rules lived on palm leaves. Today, they live in processors. We all know computers run on ones and zeros, but what if I told you those ones and zeros were first written not in code, but in verse? Long before binary was powering machines, it was powering meter in Sanskrit poetry. Around the 3rd century BCE lived an Indian scholar named Pingala, a poet, a prosodist, and a mathematician. He wrote a text called the Shastra, the science of poetic meters. His work wasn't about mysticism, it was about metrics, the mathematical patterns in Sanskrit poetry. But hidden inside his verses was something revolutionary. In Sanskrit prosody, syllables are categorized as either Laghu, Laghu, short syllables, Guru, Guru, long syllables. Think of them like binary digits. Laghu equals 1 Guru equals 0. That's right. Sanskrit poetry was already working with a binary system, centuries before Leibniz or Boolean logic. Pingala's algorithm, the Prastara. Pingala created an algorithm called Prastara, meaning to unfold. It generated all possible combinations of short and long syllables, like a truth table in binary. Let's say you wanted all combinations of 2 syllables. 1, Guru Guru 2, Laghu Guru 3, Guru Laghu 4, Laghu Laghu. Now, replace G with 0 and L with 1, 1-002-103-014-11. You've just recreated the binary system. Pingala's method didn't just predict syllables. It structured binary permutations centuries before they were formalized in mathematics. Binary in action. Example. Let's go further. Let's convert the number 237 to binary. Decimal 237 equals 1 times 2 to the power of 7 plus 1 times 2 to the power of 6 plus 1 times 2 to the power of 5 plus 0 times 2 to the power of 4 plus 1 times 2 to the power of 3 plus 1 times 2 to the power of 2 plus 0 times 2 to the power of 1 plus 1 times 2 to the power of 0 equals 128 plus 64 plus 32 plus 0 plus 8 plus 4 plus 0 plus 1 equals 237 equals binary 11101101. This is exactly the logic Pingala described in a poetic context. Binary is the main foundation of computing. Everything from microprocessors to machine learning runs on ones and zeros. But Pingala saw this system first, not in machines, but in a meter. His insight, structure plus simplicity equals infinite combinations. And that's the same principle behind programming languages, logic gates, and AI models today. Here's the twist. While the West credits binary to the 17th century, Pingala used it not to calculate, but to compose. He didn't just discover binary, he turned it into an algorithm for art. In a world now run by binary, his poetry reads like prophecy. Long before computers existed, before silicon chips or logic gates, a Sanskrit scholar wrote a system so simple, so structured, that it could power both verse and code. Pingala didn't just write poetry, he wrote the first binary manual, and 2,000 years later, his code is still running. A sutra isn't just a verse, it's a rule, short, dense, and packed with meaning. Think of it like ancient pseudocode. It doesn't explain an idea, it encodes it. You unpack it through deep study. Just like a compiler parses code, ancient scholars interpreted these compact rules. Indian thinkers didn't just write about logic, they wrote in logic. Take Rishi Canada, a philosopher from around 600 BCE. He described gravity in a single compound Sanskrit word. Split it apart, and it maps like this. Attraction plus objects plus downward equals gravity. Not just poetic, algorithmic. One rule, infinite applications. Now jump to a famous puzzle. The knight's tour. A knight visits every square on a chessboard exactly once. In the 9th century, poet Rudrata encoded a full solution. Not as code, but as verse. Each syllable, a knight's move. The path was sung, not printed. That's not just art, that's logic, in rhythm. Even Aryabhata, around 500 CE, used poetry to encode numbers. With the Akshara Samkhya system, he mapped digits to letters. Each verse in his work carried precise math. Compressed, memorized, chanted. Sound familiar? That's lossless data compression, but in ancient style. But why poetry? Why rhythm? Because in oral cultures, memory had to be perfect. Chanda, Sanskrit meter, wasn't just musical, it was structural, like a database schema. It helped store, retrieve, and verify knowledge with zero error. So no, and our ancestors didn't write Python, but they did write principles. They built logic systems, encoded algorithms, in chants, in verses, in structure. Today you hear names like ChatGPT, BERT, GPT-4, modern language models. But the blueprint? It was written 2,500 years ago by Pāṇini. Let's break this down. What does a transformer do? It splits your sentence into tokens, small, meaningful chunks, then applies rules based on context, layer by layer, to generate meaning. Now look at Pāṇini. He took root words, broke them into linguistic units, applied contextual rules, and generated grammatically correct expressions. Both systems rely on tokenization, context awareness, recursion. Rule-based generation. Pāṇini wasn't just describing Sanskrit, he was generating it, like a language model. Now here's the twist. Today's AI is data-driven. It learns from vast corpora. But there's a whole other field, symbolic AI, where meaning is built from pure rules and logic. And guess what? Pāṇini's grammar is one of the greatest symbolic systems ever created. No hallucination, no guessing, just structure. Let's clear something up. Programming isn't about language, it's about logic. Python, C++, Sanskrit. In the end, it's all just ones and zeros. To a machine, if and yeti are the same, voltage flows. So can Sanskrit be used to code? Sure. You could write Yedi ke das, che ke dvitiya, anyata, che ir ke triti, just like Python. But ultimately, it all becomes binary. So is Sanskrit better? Not exactly. What it does offer is powerful. A formal structure, like context-free grammars, clarity for symbolic models, precision for speech systems, elegant rule generation. But hey, other languages offer this too. The point isn't that Sanskrit is magical. The point is, it's structured. So where are we now? Is Sanskrit fit for programming? Yes, structurally and philosophically. Is it better than Python or English? No, it all compiles the same. Does it help symbolic AI? Absolutely. Is it required for AI progress? Not at all. NLP is multilingual. Does it add cultural and intellectual value? 100%.
Question is, what is research, especially in social science?
Finding out things that your grandmother already knew.
Before code, there were chants. Before syntax, there were sutras. And long before machines could think, Sanskrit already had. In our case, our grandmother didn't just pass on stories. She passed on systems, recursive logic, linguistic precision, and a structure that still runs today. Sanskrit doesn't need to power machines to prove its brilliance. It already is one of humanity's greatest intellectual feats, a language that defined itself, using itself.